If you've been following the headlines lately, you've probably seen all the warnings about the dangers of running autonomous AI agents. It could be accidental data leaks or high-profile security breaches like we saw with OpenClaw. The reality is that giving an AI agent full access to your host terminal is pretty dangerous. But we're not gonna stop using these tools just because of security concerns, right? What we need is a better sandbox. And there's this little incredible tool out there called Code on Incus, which lets you run Claude Code in a completely isolated Incus container. So you can safely run your coding agents without worrying about having your SSH keys or environment variables leaked. In today's video, we're gonna take a closer look on how Code on Incus works, and then I'll show you how to set it up yourself so you can safely start running your own fleet of autonomous AI agents. It's gonna be a lot of fun, so let's dive into it. So first of all, what is Incus? Well, actually, I covered Incus in greater detail in one of my previous videos, so go check that out if you want to dive deeper into how it works. But essentially, Incus is an open source system container and virtual machine manager that allows you to run full Linux systems in isolated environments. And Code on Incus takes this idea to the next level by letting you deploy fully isolated mini Linux machines with Claude Code pre-installed on them so you can use them as sandboxed Claude Code agents. It's a pretty cool idea. It basically gives Claude its own dedicated Linux environment. And unlike Docker's privileged mode, Incus system containers behave like full Linux machines. And they also have a persistent state, so you can stop and start sessions without losing progress or conversation history. One of the best parts about this setup is that it solves the permission hell. Usually when a container creates a file, it's owned by root, and you're stuck running chown just to edit your own code. But Incus uses UID mapping. So it effectively tricks the system so that everything Claude creates in the sandbox is natively owned by you on your local machine. And in my previous video, I showed you how to set up Incus containers on a Linux machine, but this time I will show you how to set them up on a Mac. So we will basically be using a tool called Colima, which is its own container, and we're going to be running Incus inside of it, which is another container, and we're going to be running Claude Code inside of that, which is a true Inception-style scenario. So first and foremost, make sure you have downloaded Colima. And on the right over here, I have set up a simple folder called My Test App, where we will store everything that Claude Code produces through our Incus containers. So now let's start a simple Colima instance, and we will pass the mount flag to allow writing permissions to the folder that I just created. Once we've done that, we will SSH into our Colima container, and from here we basically need to follow the instructions laid out in the Code on Incus repository. So copy these lines to install and configure Incus, and then it says that we should run the bash command, but in my previous tests, this didn't actually work as expected, so instead, you can do the same thing by copying the contents into an install sh file and then running that. The setup script will now run, and it detects that Incus is already installed, which is great, but we still need to configure our firewall. But we will do that in a moment. Right now, just click 1 to build from source and let the script do its job. Once you've done that, we can go ahead and run our firewall configuration commands. And according to the instructions, the next thing you should do is run koi build, but in my previous tests, I encountered some network connectivity issues. Since Incus is running inside a Colima virtual machine, it creates its own virtual network bridge. Usually it's called Incus BR0 to give Claude containers internet access. But here's where it gets tricky. By default, Linux firewalls and even Docker's own networking rules can sometimes conflict with this bridge. To fix this, we need to ensure that the Colima virtual machine allows traffic to flow freely between the Incus bridge and the outside world. We do this by adding the Incus bridge to our trusted firewall zone and enabling IP version 4 forwarding. And once you see success printed out twice in the terminal, we are now officially ready to build Code on Incus. Now the documentation can be a little bit confusing here because to build the tool, you need to run a setup script, which is inside the repo. So the easiest way forward is to clone the Code on Incus repository directly, then cd into it, and then run COI build from there. At least that's how I got it working. The build process takes about a minute or two to compile everything, but once that's finished, then the fun begins. We can now finally spin up our autonomous Claude Code agents inside their own Incus bubbles. So let's do that now. To show you how this works in practice, I've set up two terminal windows. I'm launching our first instance on slot 1, passing in the workspace path so Claude knows where to save the files. And I'm also adding the network open flag, and this is crucial because it allows the agent to reach the internet, download dependencies, and hit the APIs it needs to function. I'll do the exact same thing for slot 2, essentially creating like a tag team duo. One agent will be entirely focused on the back end and the other is dedicated for the front end portion. For this demo, I'm going to ask them to build a Star Wars holocron app, a tool that fetches character data from the Swappy API. And to make it more interesting, I've also asked the front-end agent to give the UI a flickering blue hologram effect inspired by the classic 1977 Star Wars terminal look. And then we just let them cook. And a few minutes later, we see that both of our agents have successfully collaborated, working in the same workspace, and they've created both the backend and the front-end interface. So now let's open the browser and see how it looks. Okay, so it's looking pretty good. We have that classic Star Wars hologram glow effect going. And now if I query data about Darth Vader, we can see it successfully retrieves it. Same thing for Yoda, and same thing for Luke Skywalker. So this is the power of safely orchestrating AI agents without ever exposing your primary host machine to unknown dependencies or messy code bases. And now I want to show you another example where this kind of security is very useful. So let's say you've downloaded a file and you suspect this file might contain malware, and for this demonstration purposes I will actually use a sample malware file provided by the ACAR Institute that is usually used as a demonstration file mimicking a real computer virus. Now the file in essence doesn't do anything harmful, but it does contain a malware signature inside of it. So now let's suppose you have that file but you don't want to unzip it on your local machine. So this is where again you can use code on Incus to do the archive extraction for you, and then maybe we can use Claude Code to run a comprehensive analysis on the contents of that file. So in this second example, I've started a new Colima instance, and this time I'm passing in the folder that contains the ACAR file as a workspace, so we can then pass it to Incus. So I've gone through the whole process again of installing COI and configuring it, and now we've launched a new AI agent. What we can do now is in a separate terminal window, push the file onto the Incus instance, and you can do this by using the Incus file push command and by specifying the container ID of that particular COI instance. And once we've transferred it, I can now ask Claude Code to examine the contents and run a comprehensive analysis report. So a few moments later, we see that Claude Code has finished the analysis, and as expected, it has determined that this file is completely safe and not malicious at all. And it did identify that this is indeed an ACAR malware test file, and it has laid out all the details of it in the analysis report. So this is pretty cool. If you're a security researcher or just a developer who receives a lot of untrusted files, you can definitely use the same process to safely and securely inspect them. You can get all the analytical power of Claude with the impenetrable shield of an Incus system container. So there you have it. That is code on Incus in a nutshell. There are all sorts of other helpful commands this tool provides that I didn't get the chance to highlight in this video. Like for example, you can launch instances with your own custom images, and you can manage snapshots and sessions. So do check out the full project to get a deeper dive. I think nowadays with so many security threats on every digital corner of the web, tools such as this one really helps to manage AI agent orchestration safely, and it's using Incus to do so, which I'm a big fan of, so that gets my stamp of approval. But what do you think about this tool? Have you tried it? Will you use it? Let us know in the comments section down below. And folks, if you found this video helpful, please let me know by smashing that like button underneath the video, and don't forget to subscribe to our channel so you don't miss out on any other of our future technical breakdowns. This has been Andres from BetterStack, and I will see you in the next videos.